Alright, so Unit 5 is all about chemical reactions and the equations that describe them. So your lab on Friday was about one of 6 classes of reactions you must be able to recognize from the reaction or partial reaction and write down on paper. Okay? Some classes of reactions you must be able to, you'll have both reactants and products. Some reactions, or equations rather, will only have the reactants, and you have to predict the products. So the post lab you did was all about predicting products of a type of reaction called a single replacement reaction. All right, now, what is a single replacement reaction? It is kind of what it says it is. Okay? It's one thing replacing something else. It's also called a single displacement reaction. I actually prefer the term single displacement. Because displacement kind of means kicking it out. Alright? If I have, well, to use the famous example of a Greek, ancient Greek thinker and engineer, and some people will even call a scientist, you get in a tub of water, the water rises. That's you displacing the water. Okay? Single displacement is one part displacing, or kicking out, or pushing out another. So using the examples from the lab that you did, one of the reactions we ran was zinc and copper nitrate. And so we'd write it something like this. Here's the zinc. Now we need a physical state symbol. Now a physical state symbol just tells me the physical state. Well, that zinc, when we put it in the solution, was a solid. Okay? And we put it into a solution, in this case, of copper nitrate. Now, copper nitrate, if it's not in water, is a solid. But when we put it in the water, it dissolves. And that's where you got that blue color from. The copper nitrate, when it dissolves, or actually the copper too, when it dissolves in water, has a blue color. In fact, the copper nitrate has a blue color. But it really does adopt a blue color, and there are some forms of copper compounds that become only blue when you dissolve them in water. But we'll get a blue color. Well, that's called aqueous. AQ. That means dissolved in water. Aqueous means dissolved in water. So what you saw evidence of when you did that lab is you saw evidence the zinc went over here and kicked out the copper. Now when that happened, the zinc actually became an ion. Okay? The zinc metal became an ion. It became zinc 2+, because that's the only charge that zinc has. And you can look that up on your periodic table with oxidation numbers. But the copper comes out as a copper metal. Now you probably didn't see evidence of that, but if you worked with it long enough and allowed it to sit long enough, you'd probably see little tiny pieces of copper in the bottom if you knew what you were looking for. Okay? So then the products on the other side of this chemical reaction will be solid copper. And what's actually in solution, and the reason that zinc dissolved or seemed to dissolve, is because it now is zinc bonded with the nitrate. Or it's actually in solution separately from it, but that's okay. So this is aqueous. It's dissolved in the water. If we were to allow the water to evaporate, we get copper metal and zinc nitrate. We could actually collect the copper metal through filtration, and then we could allow the water to evaporate and get a crystal that was copper nitrate. Now we need to balance this formula. That's what we did in the last unit. We learned to balance formulas. Okay? So, balance this formula, zinc and nitrate. That's your assignment now, to balance the formula, zinc and nitrate. You have all the tools you need in your test references. I want you to balance that formula. That's what you're going to have to, one of the things you're going to have to be doing or have to do in this unit.